Okay, in this video we're going to talk about how to simplify algebraic expressions. So I'm going to start off by talking about what exactly does that mean. An algebraic expression is just a combination of numbers using our algebraic operation. So plus, minus, times, divide. So for instance, this is an algebraic expression. It's a combination of numbers using our algebraic operations. That's different from an equation, which should have this expression equals this other expression. So an expression just has a single number, essentially. It's maybe written in a more complicated way like this one is, but it does represent a number, not an equation, which is a true or false statement. Okay, in the previous video we talked about a couple of rules of algebra, and I wanted to refresh your memory because we're going to add one more in order to help us with this particular problem. So the two that we talked about already were the fact that you can add two numbers in either order, which is called the commutative law, or commutative property of addition. The second one says that if you're adding three numbers, you can add them in whatever order you want. So we could put parentheses around the A and the B, or we could put parentheses around the B and the C, and they should add up to the same thing. This is called the associative rule, or associative property of addition. Both of these are also going to be true if we replace addition with multiplication. So just super quick, if we have A times B, it's the same as B times A. If we have A times B times C, it should be the same as A times B times C. So again, this is a commutative law, we switch the order. This is an associative law, we switch which things are paired up first. And again, all these mean that you can add a chain of numbers in any order you feel like. You can multiply a chain of numbers in any order you feel like. We have one more rule to talk about, which is the distributive rule. Distributive law, which is how do we combine, or how do multiplication and addition interact. And it says the following. If we have a number times a sum, we have to multiply that number times both parts of the sum. Or we have to distribute, it has to go to both places. So we have A multiplied by B and A multiplied by C. And so the idea here, if I just make a really quick example, if somebody promises you $3 and then they also promise you $1 and then they say, wait, I'll double it. You're expecting them to not just double the 3 and not just double the 1. You're expecting them to double the total, 3 plus 1, which would mean you double the 3 and you would also double the 1. Okay, so that's how the distributive rule works. Something else that's hidden in these things that I've written down is that we're not always consistent with how we write multiplication. Sometimes we'll use a little asterisk, sometimes we'll use a dot, sometimes we won't use anything if it's clear that those are not trying to spell ab, it's trying to be a letter A and a letter B with some operation between them, and then we assume that's multiplication. So same thing here, we have a 12 in front of a parentheses, there's got to be some operation there, so we're assuming they mean multiplication. So 12 times implied multiplication, this quantity in parentheses. As we talked about before, order of operations says you're supposed to do the things inside the parentheses first, which mean 1/4 plus 2/3. And so if I wanted to do that, I could say use a calculator and say what is 1 divided by 4, what is 2 divided by 3, and then add their totals. But that's not the way I'm going to do it. I'm actually going to try and use the distributive rule just to see if that makes my life easier. It turns out it will in this particular example. So if I have 12 times the sum, that's the same as distributing 12 times both pieces, 12 times 1/4, and 12 times 2/3. So 12 times 1/4 plus 12 times 2/3. Okay, so just to kind of talk about why this would be helpful, it's really easy to multiply a fraction by a whole number because a whole number is really a fraction, implied fraction. It's as easy as possible. 12 is the same as 12 over 1. Twelve divided by 1 is the same thing as 12 itself, so we can always write a whole number as a fraction. And then rules of multiplying fractions say you just multiply the tops and you multiply the bottoms. So 12 times 1 and 1 times 4 would give me 12 on top and 4 on bottom. 12 times 2 would be a 24 on top, and 1 times 3 would be a 3 on bottom. So I'm just multiplying the numerators of the two fractions, and I'm multiplying the denominators, the bottoms of the two fractions. And then if you stare at those two fractions, those are actually easy divisions you should be able to do in your head. 12 divided by 4, if you have a dozen, you split it between 4 people, that should be 3. And 24 divided by 3 would be 8. I'm running out of room on the board, so I'm going to say equals 11. When you're writing down things in mathematics, feel free to always work left to right or always work top to bottom, but because of the way paper works out and sometimes we run on a page, we'll probably use a combination of up and down steps and left to right steps. Each of these we've written equal sign to say each of these expressions is equal to each of the other expressions. So simplify 12 times 1/4 plus 2/3, well, it's the same as 11. 11 is a much simpler way to say 11 than 12 times 1/4 plus 2/3. They're equal, but one much simpler. Okay, let's try another example of simplifying an expression. Let's do 2 plus 3 times 5 minus 7. Okay, so again, order of operations, we have to do multiplications before we do additions and subtractions. This is the only multiplication. There are no exponents, there are no parentheses. So we'll say this is 2 plus 15 minus 7, and then we add or subtract left to right. This is already written in the way I would want it to be written. Positive numbers first, negative numbers last. 2 plus 15 would be 17 minus 7. And 17 minus 7 would be 10.